Hi everyone, welcome to my YouTube channel Networking Made Easy by T.S. Srinivas. So in continuation with our last lecture, today we are supposed to learn about the transmission impairments. Okay. So before knowing more in detail about the transmission impairments in my next session, so here we are going to discuss a very important thing. So basically in any transmission system or a communication system, one important parameter is the word called signal strength. Signal strength. Okay. So we already know that the signal is having a strength because when any signal is being transmitted, it has to pass through the transmission medium and reach to the receiver. Okay. So this signal strength, time to time, say there used to be a loss. See, when it is traveling through some, there used to be attenuation. We always talk in terms of attenuation. Means it's a loss when it is passing through a medium, or sometimes certain passive elements in the transmission system at certain places will be using like splitters, directional couplers, certain pads, or taps, something like that. Okay, so at these components, some energy will be lost. So this particular loss, the loss in the signal strength, generally falls in logarithmic way. So it is always convenient to represent this particular loss in decibels. Okay, so that's what we are going to learn today. What is this particular term decibel and how it is useful for us? Okay, so it is always convenient to us to represent this particular attenuation, okay, loss in terms of decibels. Okay, so how this is calculated? You just see the number of decibels. Number of decibels is equal to 10 log. This is actually the power ratio. Okay, see, actually it's a measure of ratio between two powers, anything like that. You will be learning more in detail. Okay, so here we are talking about the power level. Signal strength means its power. So the ratio is being represented in logarithm, and finally you get the value in dBs. Okay, so to understand better, we'll take one small example. Say you are giving some signal with the strength, means some power of say 10 milliwatts. Okay, so it has passed through some transmission medium. Okay, and you got some output like 5 milliwatts. Okay, so here your power 1 is 10 milliwatts and the power 2 is 5 milliwatts. So there is a loss in the transmission line. So if you substitute in this particular formula, you get 10 log 5 by 10, so which is equivalent to 10 into minus 0.3. If you calculate this with the base 10, so you will get this value. So we are able to tell that it is minus 3 dB. So you are expressing the loss in terms of dB, 3 dB. Okay, so this number 3, you better listen at many places, 3 dB. Okay, so it is actually, it's a relative thing. Like for example, you take another example, suppose you are giving input is 1000 milliwatts. Okay, output says 500 milliwatts. Okay, again if you substitute the values, the ratio of 500 by 1000 is again it is half. So you will be getting minus 0.3. Finally it is again the loss in 3 dB. Okay, so when you listen this particular 3 dB means minus 3 dB means what? The power is becoming half. Okay, so to understand better, like even when you are working with the filters, okay, a band pass filter, its characteristics is shown like this. Okay, so generally a band pass filter, what it does is it allows certain range of frequencies. Okay, so what we expect is what all the useful frequencies should be passed So for example, in our audio frequency range, like it starts from 300 Hertz to 3400 Hertz. So all the frequency components, it should be passed without any attenuation. Okay, so that the further circuit will process this particular signal. Okay, so that's why the characteristics will be, see, in this flat part will be shown as 3 dB. Okay, and finally when it is falling, isn't it? Okay, you will take the value up to 3 dB. Means the power is falling up to half, up to that it is having certain meaning. Below that, okay, it falls very drastically, so it is of no use. The circuitry will not reject it. Okay, so that's why here also upper cutoff frequency it is minus 3 dB. Okay, so this is nothing but our bandwidth of that particular filter. Okay, so this 3 dB term is everywhere used. Okay, so this particular dB, it is not only representing loss, we can represent the gain also. So you generally see when this particular signal strength is getting attenuated through passing through some transmission elements, okay, then some places you may be required to amplified, you will be using amplifier. Okay, so the amplification, because that is also expressed in gain, because you are getting increasing the power level, so you are representing in the gain. So that gain also can be represented in the dB. Okay, so for that we will take another small example. Say our signal is passing through some transmission element in a transmission path. Okay, say this is one is some transmission line, say some medium, okay, and here is the amplifier, another transmission medium. Okay, you are giving an input of say 4 milliwatts. Okay, and whenever it is passing through some medium, there is a attenuation. So attenuation is always expressed in minus. So say there is a minus 12 dB loss, and you have amplifier, it's a gain, it's a positive. So it is, say it is having a 35 dB amplification gain. So again it is passing through the another medium, there is a loss of 10 dB. Okay, so finally you are getting some power. Okay, so to again calculate, you just see, that's what the gain or loss can be calculated by adding or subtracting easily by this particular values. Okay, so you can simply say minus 12 plus 35 minus 10, result is 13. Okay, if you equate this, 13 dB is equal to 10 log, and you don't know the power, so input power is 4, so the result is P2 is equal to, so 4 into 10 to the power of 1.3. If you calculate, you will get around 79 milliwatts. Okay, so that's why it is so convenient using the decibels. Okay, even the power ratios, so whenever you listen to this power ratio, the power ratio is 10, it is said to be 10 dB. Power ratio is 100, then it is 20 dB. Okay, so for example, if I am telling a gain, the amplifier gain is 30 dB. 30 dB means what? The gain is 30 dB means it amplifies 30,000 times. Okay, see, for example, you are giving to an amplifier, your input power is 1 milliwatt. Okay, then if the gain is 30 dB, the output will be 1000 milliwatts. Okay, so it amplifies by 1000. You give anything, it amplifies by 30 times, means 1000 times. Sorry. Okay, so that is what is a power ratio. I mean, that's why it is useful. 10 dB, 20 dB, 30 dB. Even this 3 dB also, for example, your input power is 100 milliwatts. So there is a 3 dB attenuation. 3 dB means it has become half. Again further you have a 3 dB addition. This 50 will become again 25, again 3 dB, then it becomes further 12.5 likewise. 3 dB, 6 dB. So these power ratios, if you are having certain references in your mind, the calculation becomes so easy when you are working with real-time circuits and all. So this particular representation decibels will be very easy. Okay. So further to this, we can use this particular dB for representing as a means refer to a absolute level of power or voltage. Okay, in some cases, like this can be represented dB, the power dbw. Okay, the power dB, sometimes you might have watched the power is in dbw. What actually it means? Here it means the reference power is 1 watt. You are using the reference power as 1 watt. So based on that, you are calculating the output, means you are representing that particular values into the dBW form. Okay. See, for example, if you are replacing this power watt in power also as a 1 watt, then what will be the power in dBW? It will be 0 dBW. Okay, 0 dBW means it is 1 watt. Okay. So that's how it is, because if you are you can use this particular decibels for representing powers also. Okay. For example, if I am telling the power is 30 dBW. Okay, what it means? So already we have seen. Okay, so the power is represented in watts. So output simply you can say it is 1000 watts. Okay, the absolute power is nothing but it is 1000 watts. So it is so easy to represent dB form. These all levels also into the dB form. Okay. So this particular kind of powers, when you are talking in terms of watts, generally we will be using in the microwave applications where high powers are there. Sometimes it's a good practice, like in wireless communication systems and all. If the powers are in milliwatts, okay. So there is a general practice to represent the powers in milliwatts. So in that case, the reference will be, the reference value will be milliwatt, 1 milliwatt. Okay. So then whatever the power values are there, you are representing in milliwatts. So here in this case, 0 dbmw is equal to 1 milliwatt. Okay. So this is also dBs or decibels are being used for representing absolute values also with certain level. Okay. And this also can be used to represent in voltages. Okay. So generally the people working in cable networks or broadband LAN networks, okay, actually where in these places the powers are very less. Powers are in the terms of microwatts or nanowatts, because this signal, the power is sufficient for the receiver. Receiver sensitivity is so good that it will be able to process the signal very efficiently with this particular power levels itself. Okay. So that's why there we always talk in terms of millivolts. Okay. So that's why you just see here, because you can convert into the voltage form also. We know this particular formula, power is equal to V square by R. So if you replace, okay, this with power in this particular formula V square, so what we are going to get is 20 log, okay, V2 by V1. Okay, 20 log V2 by V1. So this is what you can extend this particular decibel formula for the representing voltage also. So that's why here it's a practice that these voltages in this particular networks, you will be familiar with dbmv. Okay. So what it does means the reference value is 1 millivolt. Okay. So that's why the people who work in this particular area, they will be talking in terms of millivolts. For the maintenance also, when they understand, they start measuring the powers in terms of millivolts at different levels, they can easily identify where actually the problem is. So this decibel representing these things, there is an important application of the decibel at the different places. Okay. So this was a very small session. Okay, if you have good understanding towards the decibels, so you can easily follow, especially when you are in the next session, you will be talking about the signal to noise ratio, how the signal power and the noise power ratio is being represented in the decibels. So you will have a better understanding that time. Okay. So that's all for this particular session. Thank you. Keep watching my sessions. Bye.